Not yet. X is the input into the function f. I actually went to bed at 7 last night because I wasn't feeling good. So did not make cake. So x is the input. So another way you can write that is f of input equals input squared minus 3 times my input plus 5. Okay, so that's what x is your input. F of x, or the y, is your output. When we put in x into the function, out pops our y value. Okay, so f of 7 is saying my input into the function, and we're replacing x with 7. So it's going to be 7 squared minus 3 times 7 plus 5, which is, 7 squared is 49 minus 21 plus 5. So 49 minus 21, 28 plus 5, 33. F of negative a. So now our input is negative a. So wherever I see x, I'm going to put a negative a. Okay, what happens when you square a negative? Positive. So a squared. And then we're going to have 3 times negative a minus 3a plus 5. What? Oh, it was a minus 3. Oh, got ahead of myself. Plus 3a. Plus 3a. There we go. Okay, and now what if my input is now 2x minus 1? So we have 2x minus 1 all squared minus 3 times 2x minus 1 plus 5. What are we going to have to do here? FOIL. Okay, we can do this 2x squared, 4x squared. To get the middle term, we take the two terms multiplied together and double it when we have a perfect square. So negative 4x, the middle term, and then square the last one, plus negative 1 times negative 1, 1. Bringing in the negative 3, negative 6x plus 3, and now we can collect like terms. So we have a 4x squared. How many x's will we get? Negative 10. Continue. Okay. And how many ones? 9. There we go. Good times, right? So you remember that from back in grade 10, right? We did it. But you know it now. It's like you're used to functional notation. Yeah. Perfect square. You square the first. Middle term times these together and double it, because they're going to be the same middle term. And then square the last. And double it to get the middle, and then square the last. No, it's not. Once you know that, it's a pattern, right, for perfect squares. So you can just FOIL it out if you want to. The middle term you multiply, because it's going to be a 2x times a negative 1, and then a negative 1 times a 2x. So they're identical. That's why it's double. So you just take one of those products and double it. Okay, try the next one on your own. Well, let's try A and B by yourself. Try A and B. Okay. Adrian? Should you come up and do A? Yeah, why don't you? Okay, tell me from here. No, just sub it in first. Minus 3 times negative 2 squared. What happens when you square the negative 2? Positive 2, so you're actually getting 5 minus 3 times 4 is 12, which is negative 7. Okay, next guy, somebody want to do it on the board? Okay. Okay, Tyler, here, knock yourself out. I know. You can say hi. Do you want the mic? Yeah.
All right, All right, class. I don't know how this works.
Put it on your neck. Just wear it on your neck.
That's different than Tim Hortons. Okay. So you have 2x minus 7, but you replace the x with x minus 4. Minus 7 equals, so, distributive law thing. Negative 8 minus 7 is, I don't know. Sure. You tell me that.
Okay. All right, there you go. Thank you. Very good. Hi. Okay, and last one. 6 times f of 0. So let's do this all at once. 6, so f of 0. So I'm going to negative 7. So yeah, so you're doing 2 times 0 minus 7. I'm just going to write it out. Minus 10 times g of negative 1. So 5 minus 3 times negative 1 squared. So 6 times negative 7 minus 10 times 5 minus 3, which gives you 2. So 6 times negative 7. Negative 42 minus 20 minus 20, which equals negative 62. Very good. Okay, so that should be mostly review. Let's look over at composite functions. Or, yeah, combinations of functions, sorry. And then we'll look at a composite functions. Okay, so combinations, you can have a problem. Right, you've seen this all in Math 30-1, right? So we can skim by it. Okay, so domain is going to be, well, it says A intersection B. So we're using F. So our domains, if we're adding or subtracting, it's going to be the intersection of F and G to get our new domain. Okay, are these functions. So we'd separate, find the domains of each, and it's the intersection of the two. For all of these. For all of them. Okay, so let's look at the next problem. So it says find the domain of this guy. Okay, so first we're going to call f of x 1 over x minus 7, and we'll call g of x 2 over 5x plus 3. Okay, so our function, we're going to call it f of x plus g of x. Right, so we're breaking into two separate functions. Why are we breaking into the two? Well, there's two places that are affecting the domain. Right? So let's find the domain of f of x. So how would you find the domain of this guy? X minus 7 can't be equal to 0, therefore x can equal 7. Okay, and what about the next guy? Okay, so 5x plus 3 can equal 0, so x can't be equal to negative 3 over 5. Yeah, negative 3 over 5. So our domain would then be both, we need both of those, right? Because if we take this function, and this function is x can't be equal to negative 7. Positive 7, actually. Okay, pardon me? No, you'll, yeah, you can. Yeah, you can have as many union symbols as you need. Okay, so this function says just x can't be 7. So it used to be, let's use a highlighter. So it can't be 7, right? But this function, yeah? Intersection. So we want to intersect them, right? And this other function said it can't be, can't be equal to negative 3 over 5. Maybe I should just put the colors a little lower and a little higher. So where's the intersection going to be in this case? except for those two, right? Which makes sense, everywhere except for those two. So our domain would be then from negative infinity to negative 3 over 5, round bracket, because it would be 0 at that point, union negative 3 over 5 to 7, union 7 to infinity. Right, so that's why it's the intersection, right? You get it? Okay. So when we want to find, or we have a complex function, we can break it up into those different functions. Find the domain of each of those, and then find the intersection. So let's look at something like this. So what is our f of x then? Yeah, we'll make f of x equal to root 9 minus x squared, and we'll make g of x root x. No, doesn't matter. Okay, we're splitting up into two different functions because they're two different radicals. So we want to split them up and find the domain of them separately. Okay, so this is really, we're saying y is equal to f of x over g of x, right? Or f, how do we write that again? It's f over g of x, right? Same thing. That's how we're going to split up y, because there's two things affecting the domain, the numerator and the denominator. So we want to split those up. Those are the two things affecting our domain. Okay, so let's find the domain of each of these. So let's start with root 9 minus x squared, or f of x. Maybe I'll write f of x equals. Doesn't matter. So what do we know about that guy? Can't take the square root of negative, so 9 minus x squared has to be greater than or equal to 0. So let's solve this. So what do you want to do first? So you want to move the x over? Add x squared. Okay, I'm going to do an interval test whenever we have these situations because you guys tend to make mistakes. So what are our critical values here? Positive 3 and negative 3. Cody, you're with us? Can you put that down during class? Thanks. Okay, so if I put in negative 4 and square it, will it be less than 9? So let's see. Negative 4 squared would be 16. Is 16 less than 9? No. So try 0. Is 0 squared less than 9? Yeah, so it's in between here and here for this guy. Now let's look with, this was our f of x, so let's look at g of x. So root x, what's the restrictions on x here? Can't be 0 and, oh no, it could be 0. Has to be less than 0. Can't be less than 0. So we can't take the square root of a negative. So x is greater than or equal to 0. Okay, so what are we going to do with these two guys? Union or intersection? Not really, but okay. We're going to find the intersection. Okay, so I'm going to draw this. We want to find the intersection. So we have negative 3 to 3. Right, was this guy? And then 0 greater than 0. So what's our domain? Oh, you know what, guys? We missed one. Why can't it equal to 0? Why can't it be equal to 0? It's on the denominator. So this is actually open, closed. Because it's on the denominator. We have to be careful of our NPVs. So it actually can't be equal to 0 there because it's also on our denominator. Okay, so so our solution then would be from 0 to 3 close bracket would be our domain. So the intersection of the two. It doesn't ask us to find the range. It's more complicated, so we're not going to. No, for these ones, just finding the domain. Yeah. Okay, next guy. I helped make it. No, my class stuff. It was me and another teacher at Center High back in the day. Back in the day, that was like 8 years ago. Yeah, let f and g be two functions with domain a and b. Okay, the first thing we need to know, remember this is f of g of x. Have you been learning about this? Yes, woohoo! F of g of x, right? It's an open circle here, f of g of x. It's important to know that f of g of x is not necessarily equal to g of f of x, right? Well, it's very rare that happens, but usually not. So we say it's exactly. Okay, right. So they don't equal, they're not the same thing. Okay, g of f of x is not equal to f of g of x. Let's keep it as that, keep it simple. Okay, so let's look at an example, because you should know how to do these. So can you try number 1 then? Find f of g of x, and then find g of f of x. Yeah, do B as well if you finished A. Make sure it's the same. It's nice when things are overlap between your classes, hey? No? Oh, okay. So 5 minus 7? Okay, so you're going to have to FOIL this guy out, right? So this is a perfect square. 25x squared. And then this would be 35x doubled, be minus 70x. And then plus negative 7 squared is 49. And bring in that negative and simplify. 1 minus 49, negative 48. I don't know what was going through my head. Thank you, Tyler. See, that's more of you need to come up here. You're in the spotlight. All of a sudden, your brain can do stupid things. What game? All right, how was that? That was okay? Great? Ooh, sweet. You're going to have some of that on your quiz probably tomorrow. Yeah. Okay, maybe not tomorrow. Maybe more like next week sometime. Yeah, probably Tuesday. Science 10. Sorry. Okay, so moving on. Let's solve these guys. Are we good? Do you want to go through them as well?
No.
Are we good? Yeah, we got this. It's in the bag. Okay. No? We're good, right? We're cool. Okay, let's get this. So let's move on to the last thing that's new in this unit, and that's odd and even functions. Okay, so definition of an odd versus an even function. Let's talk about an even function. An even function is even if f of negative x equals f of x. So what that means is it's symmetrical about the y-axis. Could be multiple things, but as long as it's symmetrical about the y-axis, by definition, that's an even function. Okay? So we're not talking about even exponents, but often they will have an even exponent. Okay? They'd have to. They'd kind of have to. No, they'd have to. Yeah, they would have to. Okay, so that's so it's symmetrical about the y-axis. So how do we check if a function is even? Well, if you're given a function, f of x equals 4x squared minus 5, we're going to plug in our negative x. Okay, and if it comes out equivalent to the original function, then it's even. That means it's actually symmetrical. So let's plug in the negative. So what happens here when we square the negative x squared? Positive, is that the same as our original function? That it is. So f of negative x equals f of x, therefore it is even. Okay? No. Yeah, it's going to have an even power. So even function is always symmetrical about the y-axis. Okay, symmetrical about the y-axis. Now an odd function is actually symmetrical about the origin. Okay, so it's it's like it's rotated 180 degrees, or it's reflected in the y-axis and then the x-axis. No, not reflected in the y equals x. Because if it was reflected in the y equals x, it would look like that. Right? So it's like it's reflected in the y and then the x. Or the x then the y. So reflection in x-axis and y-axis. Okay? So it's like it's rotated 180 degrees. Okay? If it's symmetrical about the origin. So what is up here is almost double mirror, right? Yeah. Okay, so if you draw this line y equals x, if it's on the bottom here, it'll be on the top there. Yeah, it's called symmetrical about the origin if it's rotated 180 degrees. So like y equals, so linear equation? As long as y equals x the equation? Yeah, that would be odd. Okay, why? An odd function, if we plug in f of negative x, it's equivalent to negative f of x. Okay, so that's how we find out if it's odd. So it's symmetrical about the origin. So that's what it's called. So here's an example, x cubed plus 7x. So if I plug in f of negative x cubed is going to be still negative x cubed. 7 times negative x, negative 7x. What can I factor out from both of these? Negative, so that gives me x cubed plus 7x. What is x cubed plus 7x equal to? Our original f of x. So if f of negative x equals negative f of x, then it is an odd function. Yeah, most aren't symmetrical about the origin or symmetrical with the y-axis, right? Most of them have shifts, so they're not going to be symmetrical.
Why can't you take an x out of that?
Oh, you could, but I'm trying to create the original f of x, right? Because I'm trying to make negative f of x, right? So most or neither. Okay. So there's 3 questions here. We're going to check to see if they're even or odd or neither. Okay, and it says show by sketch as well. Okay, so to check if it's even or odd or neither, we plug in f of negative x and see what happens. What happens? Is it even, odd, or neither? Well, negative x squared becomes a x squared plus 3, which is equivalent to f of x. Therefore, it is even. Okay, if we did a quick sketch, this is the graph, y equals x squared, shifted. How is it shifted? 3 units up. So is that symmetrical about the y-axis? Yes. Yes, it is. Therefore, and then this is because. Because is like this. So 2 dots and 1 on below. Equilateral. Therefore, and then because. Okay, so next guy, plugging in f of negative x. I have negative x plus 3 squared. Is it? I don't know. Well, what we can try and do here is expand this to negative x plus 3 times negative x plus 3. We're trying to create the original thing. If I factored a negative out, is that going to help? No. No matter what we do, if I factor the negative out for both of them, it just gives me, put the negative in bracket. So 2 negatives just going to become a positive. So it's no matter what we do, can we make it the original with a negative outside? No. Or just make it the original? No. So it's neither. Okay. Sketching this guy. He's the graph y equals x squared shifted. How? 3 to the left. So is he symmetrical about the y-axis? No. Is he symmetrical about the origin? No. Okay, last guy. 2x cubed. He will be odd. Yeah, you can, well, no, not based on process. Okay, it's not going to work well in life, okay? Okay, so we plug in negative x. When you cube a negative, it's still negative, so that's negative f of x. Therefore, odd. All that's happening to this graph is it's the graph y equals x cubed, but what's happening?
It's stretched.
Stretched by a factor of 1/2. So it's symmetrical about the origin. Actually, it's a factor of 2 vertically. It's not applied to the x. Okay, so that's it for this lesson. Right? This is applying to the y. So it's a vertical stretch by 2. And then to bring it to the x, it'd have to go inside the cube, and then you'd have to cube it rooted, and it's more complex. Okay, grab your homework. Homework lesson 8, the second part. Your homework is the following. You believe it? We're done pre-calculus. We made it through. Okay, numbers. Here we go. 2C, 4, 5C. Remember, these are the minimum I recommend you do for your quizzes. 6E, 7A, 8, ABCD. Why? But it says solutions above. And then it says lesson 8 and 9.
8 and 9.
Okay, and that's minimum. Okay, that's minimum. That I recommend that you work on this weekend. Remember, your assignment is due the day of the practice exam. If you want to get it into me earlier, I can mark it and get it back to you sooner.